Hi, welcome back. Today we're gonna be making this system that generates a palette from an image folder, and then you can recreate like any texture you want using only those images as a palette in a sense, right? But instead of using colors, we're using images, right? And you may have seen similar systems before that you just use like a lookup or something. But what's interesting and cool about this one is that the color of each of the images is taken into account to calculate where it should be, so that if I change this input, you can see that when the this image has a certain color, then the images that make up the texture represent that color without actually changing the color of these images, right? So when this is blue, we are using blue images. When this is gets more yellow, we're using yellow images. And when we're using green, we're using green images, right? Like all from our palette without actually changing the original images. Okay. Also, my Patreon, uh, I'll have an extra video showing how to make this other more chaotic one, that also instead of a grid you can have each instance keep the correct aspect ratio of the image. That's for later. So let's start. I'm gonna delete everything, and as always, let's start with a constant that has all of our parameters. So resolution on X, resolution on Y, width and height, the grid X, so the resolution of our grid, our tile ratio, because we can have the images have different aspect ratios. So if you have like a collection of family photos, for example, it's probably gonna be 3 by 4. So you can use those and not make them square. And let's also have a maximum max images, just so in case we import a folder that's too big, or it's like really big, we want to limit that. So let's do 1080p times 1280, and our grids are, let's be like 20, and should be making 1 for now, and leave the maximum at 100. I'm gonna add a null, and we are missing the grid's resolution on its height. I'm gonna calculate that using, let's right click on the connection and insert operator, and we can add a base here, and if we go inside of the base we can calculate the parameters we're missing. So first let's select the resolution Y and resolution X, so we can divide those two with a math, my channels divide, and this is the aspect ratio of our image. I'm going to change the name here to ratio, and if I add a merge, they can send it out again. Also, let's calculate the resolution in Y of the grid. So let's only select the grid X and rename it to grid Y, and we can multiply with our ratio using a math, and combine chops, multiply. But we also need to take into account the tile ratio. So if the images are like 3 by 4 or something like that, then that's gonna affect our grid resolution. So let's another select, and here I'm gonna select the tile ratio. I'm gonna do that rename, and now we have to divide what we had before. Another math by our tile ratio. This is 1 right now, so it's not going to do anything. Command chops, divide. So there it is, and let's round our result because it's a resolution, so it should be an integer. Now this is kind of in a very messy order, so let's reorder here so we make it in a way that makes sense. Let's change that to base name, no, tracked parent, I'm sorry. And we can just pick here our orders, and I want it to be res x, then res y, then ratio. Oh, there's another ratio. What is that? Oh, these two should be on the opposite order. So because multiplication, it doesn't matter. But if this one is first, then it's gonna keep that name. So I was ratio, then grid x, then grid y, and these two are fine as they are, but I'm gonna click them anyway. There you go. This is better. Now we can go back here. We have all of our parameters. I'm gonna call this null data, so we can reference it. And let's add a RAM. This is gonna be, if you watch my previous tutorial, this is gonna be very similar in the instancing setup. So you already know what I'm gonna do here. So I'm gonna take our grid X and Y and use that for our resolution. Change that to nearest, and this is gonna be 32-bit mono. I'm gonna copy and paste that, and the second one is gonna be vertical, and we can combine those two with a reorder that is gonna make the green channel be the second input, and we need to change this to 32 float RG, and there is our UV RAM. You can see it's a square, but we don't really want it to be a square because our image resolution that we set is a vertical rectangle. So we actually need to use a math to scale the y coordinates, or the green channel. Right here, the green channel. So instead of from 0 to 1, it's going to go from 0 to the ratio, the aspect ratio, and there it is, the rectangle. And you can see, because our tile ratio is set to 1, so they're squares, you can see these dots are in a square grid. And we can now use a null, and this is going to be null pos, because these are position information for our instancing. We can add here what are we going to instance, a rectangle, and the size on x is going to be 1 divided by the grid's resolution, and on y almost the same, but instead of the x resolution, it's going to be y, but you can see it's not a square because instead of 1 we are going to divide the ratio like that. It's a square, and you may think, wow, this is slightly wrong, but I do it this way because if I just use the grid x again and, like, let's say multiply with the tile ratio, this will be correct, but it will be, because there's a rounding done here in this math, that rounding error will create artifacts when we render all these rectangles together. I'll show you in a second. So let's add a geo again, like drag the line out, press tab, and then add geo so it's connected. And what do I have here? Oh wow, sorry about that. Then a camera and a render and a constant material, and this render should have the same resolution as our final resolution that we set here. There it is. We can change this view from perspective to orthographic, the origin bottom left, and ortho width 1. Okay, now we can turn off here in our geo the instancing and use our position for the translate OP. That's going to be R and G for the channels. There it is. Now let me show you what I meant before. I'm going to copy and paste it, and this I'm going to change it. Instead of this weirdness, I just copy and paste this, and the that ratio is 1. Let me multi-copy. Just put it there to copy. Right? Rectangle. Oh my god, I had 3. Okay. Like that. And then if you look at that, it looks fine, but when I change the tile ratio, these lines appear because the grid resolution doesn't correspond perfectly because of the rounding error I mentioned before. So instead of doing it that way, I just do it this way, which looks a little bit weird and off, but it almost never does that. Okay, let's move on from that. Now we have all of this. We have our positions. We need the images that are going to be put into each one of these squares. So let's get those. I'm going to add a base that we're going to call images. So images. And this is we're gonna do all the processing for those inside of here. So I'm gonna import it with a folder. I have here in my project folder one called imps, where it's of all my images. It's important to note when you're choosing which images to use here that they are in a format supported by TouchDesigner. So PNG and JPEG and all of those. For example, something like WebP, WebB, I think it's called, isn't supported in Touch. So make sure your folder only has those. Then I don't need the name. I only need the path, which is what we're gonna reference. I'm gonna use a select just to get rid of that first row. So I row by index, and I can press 1 here. And then that one is gone. We only have paths, and I'm gonna add a sort to sort this in a random order, just so that if our maximum images number here is lower than the images inside of this folder, we can just take a random set that is within that limit, right? So I'm gonna change this to random. And now these are in a random order, and we can just use another select to grab the first 100 in this case, because that's our limit. Which in this case, because we only have 27, is not going to do anything, but if there were more, you only pick the first 100, and because these were previously sorted randomly, it's going to pick essentially just 100 random from our library, right? And let's select my index, and let me select this null data here, so we can get our maximum. So here /null data, and we only need the max images. Now I can add a null, very important null, and we can add this here, so it's gonna be at -1. So now it's gonna just pick the first 100 rows, right? Now here this null is very important because of how cooking works in TouchDesigner. Whenever you change any of these parameters, the entire chop, this chop right here, gets cooked, right? So we don't want that if I'm changing the resolution or something like that for this node to update, that's gonna make this that update. That's gonna make all our instancing and image important thing update as well for no reason, right? Optimally, we will only want our images to get imported once when you open the project and then be done, because it's a really heavy operation to be importing these many images at once. So I'm gonna add here a cook type to selective, so that only if this itself changes it's gonna cook, and this won't get cooked. We can add a null, and that's gonna get called not paths, and this we're gonna reference. Now let's add a replicator. Again, the replicator, which is gonna take a base and replicate it, and inside of each base we're gonna import our image. So here, instead of by table, I'm gonna actually use by number. Drag this here to number of replicants and set to num rows -1, because we're gonna actually use this original one as the first one, so we need to replicate one less. And this is gonna this is gonna get called item 0. So it's our master, and all the subsequent ones are item 1, item 2, and all that, right? Also, we can set these maximum operators to our max images, which is an extra layer of safety per se. If anything were to go wrong, we need to this to run this that ended up with 1,000 rows, so that this doesn't get too out of hand, right? Okay. Also, I'm gonna turn on the incremental update, so that instead of appearing all at once within one frame, this replicator does one per frame, so that because each one of these is going to have a movie file in it loading an image, if we try to do that in a single frame, the entire program freezes and it's very annoying. So it's better to have this one and just later off for a little bit so it loads everything, and then we're good. Okay. Also, something else related to that is that if this that were to change, then what I said would happen, that every single one of these items would try to load the new image at the same time before this replicator has time to only delete the ones that aren't needed anymore or resets itself. So to combat that, we're going to add a that execute here, and it's going to look at this that right here, which that execute just runs code when something happens to that, right? So here we have a on table change function. So whenever this changes, whatever is inside that function is gonna run, and we're gonna use that to activate this button right here that recreates all operators, so that instead of loading all of our images at once when we change a folder, or maybe change the sort seat right here, it goes one by one so it doesn't explode. And let's, on our replicator, add a global P so it's easier to reference here. So I'm gonna just call it image replicator. And okay, now here on table change, we can go inside and say op dot image replicator, which is this reference that we just set, and then par, so parameter, and which parameter is this one right here. And you can see it's called recreate all, and these kind of momentary buttons have a function called pulse that you can call to activate them. And now we can test this. If we change this, see this table is gonna change and it should replicate all of these components. And there it is. Nice. So enough of that preparation. Now we can get our images in. So movie file in, and here I'm gonna reference, instead of this default, I'm gonna reference this OP called null paths. OP, and here null paths. And to reference a cell inside of a dot, you give it coordinates like this between brackets, separated by a comma. Oh, and this is nullpath on its own, it's a dot dot slash nullpath, because we have to one layer up. You can see here's a person playing guitar. Let me change this to one. And there's a cheese. And right now we're looking at the first row, first column. We only have one column, so this is always going to be 0. But if we change this row number, we can get every single image, right? Cool. Now, instead of doing like that, I'm gonna use this digit from each one of the bases. And to do that, we can reference them using parent, parentheses, dot digits. And then that references whatever digit your parent operator has. So for this one, it's this base, and it's gonna be the same for every single one, but every single one has different digit, right? Okay, cool. Now I can fit this. So right now we want a square, and I'm gonna actually also get here with a select all tile ratio, because if we didn't want to square it, right? So let's do dot dot slash dot dot, because we have to go 2 levels up. You can see here we are M0, so we go up 2 images and then up again to project, to our main network. And we can say null data. There they are, but we only need coverage. I'll do the same thing that I did before. Null and set the code type to selected. And now we can just set this fit to 512, and this is gonna be whatever its width multiplied by tile ratio. I'm gonna put it there to copy it, and times tile ratio. Okay, which in this case is just a square, right? Now you can see here there's some empty space because this image is rectangular, right? It's not a perfect square, so it fits it like that. You can try different ways of fixing that, changing this fit function. You can, if you use fill, it stretches it a bit, or fill side, which just scales it up. We're gonna do something with that in a second. And now this is our image. We can do add out and change that to out image. This is gonna come up just to all, and you can see now, you can see this image from outside. We not only need the image, we also need the color. We're gonna calculate the average color of this entire image using an analyze, and it's set to average by default, and this is our color. We can do another out, and this one can be all out color. Now here again has some parameter we can play around with. If this image were to have transparency, for example, if this didn't fit correctly, we maybe don't want to take all of this black blank space into account for our color calculation. Yeah, you can see that if I change the type of fit, the average color changes as well, ever so slightly. So you could change here to, instead of none, use the alpha channel as the mask. So it's gonna ignore everything that has an alpha of 0, and you can see now it doesn't change. But these two parameters, right, the fit and the mask, we may want different things from them depending on our use case. So maybe you have a lot of images with transparency, or depending if at the end you're gonna render it with a background or not, or maybe it's an overlay for something else. So we should expose those two parameters to a higher level so we can control them and we don't have to come all the way down here and then recreate all of the operators. So to do that, I'm gonna divide the screen into two panels here and go all the way up. And here in our base, these tabs with parameters, we can actually add our own. We right click here and customize component. And first we have to create a page. I'm gonna call it just image replicator. And add page, and we can see now we have this empty page that we can fill up. And we could create one by one these two, but you can also do what you can also do here in Touch is drag this parameter over this panel, and it actually creates a copy of it. And you can set the reference expression on source, which just means that this is now referencing this higher level parameter, right? We can do the same for the mask. Oh, over here, set reference. And now when we change these parameters on our base, this gets affected. And not only this one is going to get affected, but all of the other ones, right? So now we can recreate all operators here, and we have all of our images. You can see these are a couple of empty space, but now we can change that here. I'm going to say to fill outside. And no mask. Okay, so we have, this is our palette, and we have both images and the average color that we're gonna use to actually try to match some texture, some input. So let's get that input. I'm gonna use a noise that should have the same resolution as our final image. And I'm gonna get more period and get rid of the harmonics and turn off monochrome. And there it is. And a null so we can put whatever we want here. And now I'm gonna use a remap from this reorder to use these points to remap this original image like that. And we should set this, instead of source image, to UV image. Let's make all of this nearest pixels so we can see better that this is now a grid, a lower resolution grid. And this isn't the colors are right because this is now an RG texture like this one. We should set it back to 8-bit. And there it is, our initial texture, but in a lower resolution. So this is what now I'm gonna try to match with, but only using colors from our palette. To do that, I'm gonna use this component I made, Output palette, get it from the description to download it and drag it into Touch. And what this does is just takes an image and changes all of these colors to the closest color present in a given palette that you input as a chop. So by default it has this magenta and mint. So you can see is I'm gonna change this really quick to mirrors. You can see it's our same input but only using those palettes. That palette, and you can see this when there's a bluish tone gets mapped into this bluish tone, and this pink gets mapped to that pink, and this green to that green, right? But we don't want to use this weird palette, right? We want our palette that we generated using all of our images. So how do we get all of those out of there? We're going to use a layout tab that it has this input entrance, but you can also use this field to add the name of the tops that you want to reference, and you get dragged onto here, and we can reference all of colors here. We know where they are. Let's do that. Let me do, we know it's images slash then item, right? Asterisk, because that represents just anything. So it's gonna look at anything called item and then something else, which is all of this, right? And inside of those, another slash, you should look at out color. There it is. We need to turn on scale resolution, and we have our colors. Let me make these nearest pixels, and we have these max columns that's gonna make it a certain amount, but we can just make this whatever num rows this has. So let's do that. Let's do op images slash null paths and dash num rows, right? This is 28, but that's gonna change. I could make this like just 1,000. Don't not worry about it. That doesn't seem as clean. So there it is. That's our palette, and you can tell this palette specifically is very desaturated, right, and very cool tones, very cold tones. So that's something you have to take into consideration when you're selecting which images to add to your folder. That you should, depending again of what is that you're trying to recreate using only those images, is what kind of palette you should want. Like in this case, because this is a very colorful image, we would probably prefer a more colorful palette than what I have right here, but it will work. I'm gonna add a null, and we can make this into a chop with a top to chop. And there we can plug into our palette, and there it is. That's our same image, but now only using colors from our palette, right? Which are themselves calculated from the images in our input folder. So these are only colors, right? But we don't really need the colors. We are trying to instance the images. So what we actually need is the index from this palette, right? Which index should you put in each part of this instead of this color, right? So for example, here where is this color, it should give out whatever that color index is in this palette. So that's clear. To do that, we're gonna modify these components so they also outputs the index. So we're gonna inside, and here just some GLSL. Do not panic if you haven't worked with GLSL. It's not. This is a very simple case, and you can always just copy and paste what I do, and later you can learn it better, right? So we're just looping over our input colors and storing the closest we find along the way, and at the end just input that, right? So you can see right here this outback is what gets outputted out of the shader. You didn't know. So we're gonna add another one. To do that, first in our GLSL top, right here at the bottom, there's a color buffers parameter. We can set it to 2. So now we can add a second one. I'm gonna just copy and paste this one right under it, and this one's gonna call frag index. Okay, and here, we are tracking the closest color of the minimum distance from our uh, target color to the closest color that we have found so far, and we can add an other float that tracks what index that color is. So we just call it min index, right? So the index of the color with the minimum distance, and that would let's set that to 0. Then here in this case where I'm testing if the distance we're testing to add color in the palette is less than the best color we have found, then you do this swapping of variables so that our new closest color is that color that we just tested, right? So instead of that, we also add now that the min index should be set to I, so whatever index we're at, where we're looping. And we can output that here. I'm gonna again just copy and paste this. Instead of frag color, I'm gonna do frag index. This function expects to be given a vec4, but this min index is a float, so we need to add the vec4 constructor and just use min index like that. Now to see what we did, I'm gonna add a render select to drag it in there and index 1. So this is our second color buffer, right? And there it is. This should be the indexes, right? But right now it's only 0 and 1 because this GLSL is an 8-bit fix. It's in 8-bit fixed format. So we can change that to 32-bit RGBA, and now it goes from 0 to I think it was 28, right? Or 27, or the size of our palette. And these are the indices of the closest color in the palette, which is the same index of each of the images that those colors represent. Okay, now we can output that as well. And let's make a null here. I'm gonna call it null index. Let me set it to nearest pixels. And finally, we can go to our second instancing page, scroll all the way to the bottom, and here is instance textures and texture index of P and texture index. So for our instance textures, we're gonna reference each one of those images that we have at images slash item, which item, all of them, and then inside of that out image. And now we have everything looking at the first image because we have to also give it the index. So this is the texture index OP, and which channel, it doesn't matter because this is all channels are the same, but I'm gonna do red. And there it is, our palette of images being used to recreate this shape right here. And let me make this a little smaller. You can see that the colors kind of match, right? Again, this palette I have is not that colorful and try to create something very colorful, but you can see that at least the blue gets matched with this blue and this green gets matched with this green. But we are never changing the colors of the original image. We're preserving that. Okay, now and we can change the tile ratio. Right here, for example, if you had a library with 3 by 4 horizontal images, you would do 4 divided by 3. Oh no, the other way around. 3 divided by 4. And there you go, and it will work like that. And again, you can change how you're doing when they don't match that aspect ratio, how you're dealing with that, maybe with a field. If you're horizontal and you can see they have a lot of empty space that you can deal with, maybe using alpha as a mask or none. And let's see how this looks with a different image folder. I prepare another one here. I have some logos from companies. You can see it grow. And there it is. This one does get to our limit actually. You can see this one has 416 images, but we're only taking random 100. And look at that, that's way more colorful palette, as you can see there. And let's animate this to give this time of seconds times 1.2. Look at that, looks really cool, right? And now you can see these kind of pools of color. You can deal with that, adding a little bit of noise. You can make it to random, drop the offset to 0, make it not monochrome, and play around with the magnitude. And you can see it looks like that. If you don't want that pooling, you could also, I have this pattern dithering component over at my Patreon that makes this dithering in a repeating pattern and make it look prettier to you. And also here, well, you can see in this case, some of these images get cropped because we're trying to fit them into squares when a lot of them aren't or aren't supposed to be. But that's again for the extra video over at Patreon when I make this more chaotic looking, but also I'm gonna show you how to keep the aspect ratio of each image individually. So everyone can have their own aspect ratio. So that's it. That's it. Thank you for watching this. I hope you enjoyed. If you make something with this, please tag me or send it to me on Instagram. I would love to see what you make. And subscribe if you like these videos. And thank you again. That's it. Goodbye.